In our last video, I looked at the three trigonometric ratios and I've given you what are those three ratios. So to simply remember them, we say so, ka, toa. Right? So this is sine is equals to opposite over hypotenuse, cos is equals to adjacent over hypotenuse, and tan is equals to opposite over adjacent. Now, today we're looking at calculating an unknown side. Now, remember I said that we could only use these trig ratios to find missing sides and missing angles of right angle triangles, right? So the question is to calculate the length of YZ. So you have the triangle here, X, Y, Z, and we have to calculate the length of YZ. So let's just call this side little x, because opposite the angle, the side is called little x, right? Or the common letter of this up here. Now, first we have to see what we have. So the first thing we have here is theta. So we know that theta is equals to 28.7 degrees. Then we have this side, and then we have the side that we're finding for. Now, the side that is opposite the right angle, from yesterday, we said that this side is called the hypotenuse, right? And this side as denoted by x would be the side that is next to this angle. So if we draw a little person here, so if we draw a little person here, then standing the side that is next to them or below them is what we usually call the adjacent side. So this is the adjacent side. So what we have is theta equals 28.7. We have the hypotenuse, which is equals to 12.3 cm, and we have the adjacent side, which is equals to x. Now, looking at our three trig ratios, sine equals opposite and hypotenuse, cosine equals adjacent and hypotenuse, and tan equals to opposite over adjacent. Which one carry hypotenuse and adjacent? The one that carry hypotenuse and adjacent is this one. So the ratio we have to use to solve this question would be cosine. So cos theta is equals to adjacent over the hypotenuse. Cos, we know that theta is 28.7 degrees, is equals to the adjacent side, which is x, over the hypotenuse, which is 12.3. So we put this over 1, and then we cross multiply. So x times 1 is going to give me x, and 12.3 times cos 28.7 is going to give me 12.3 cos 28.7. We want the value of x, so we use a scientific calculator and we put this in. This is going to be 12.3 cos 28.7, and that's going to give me 10.788 cm. To two decimal places, x is going to be 10.79 cm. And this is how we use cosine to find the missing side. Let's look at another example. So you have another right angle triangle here, and they want you to calculate the length of BC. That would be this side, right? Now again, we have to write down what is given. So we know that theta is the angle, so theta is equals to 35.7 degrees, and we know the side that is opposite this right angle here, that would be going that way, is our hypotenuse. And since we're working with this angle and we have to find this side, so let's call this A, and we have to find this side, then this side becomes our opposite side. because it is opposite this angle that we're working with, right? So let's write down what we have. So our hypotenuse is equals to 8.50 cm, and our opposite side is equals to A. Now looking at our trig ratios, S sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. Which one has hypotenuse and opposite in the formula? So when you look at it, it would be sine. So we have to use sine to solve this question. So sine theta is equals to opposite over hypotenuse. Sine theta, which is the angle, 35.7 degrees, is equals to the opposite side, which is A, over the hypotenuse, which is 8.50. We put this over 1 and then we cross multiply. A times 1 is going to give me A, and 8.50 times sine 35.7 is going to give me 8.50 sine 35.7. We want the value of A, so we use our scientific calculator again. So A is equals to 8.50 sine 35.7, and that's going to give me 4.96 centimeter. So the length of this side is 4.96 cm. Alright, another example. So again, we have a right angle triangle and we have to calculate the length of MO. That would be the length of this side. So let's call this side common N, right, because it's opposite this angle. Now again, what is given? So theta is equals to 43.1 degrees. If we're looking at this angle, then this side becomes our opposite side, and the side that is next to this angle or adjacent to the angle is 12.5. so this is my adjacent side. Notice in this one here now, we don't have any hypotenuse. We weren't given any hypotenuse. So let's write what we have. So the opposite side is equals to N, and the adjacent side is equals to 12.5 cm. Now looking at our trig ratio, since these two carry hypotenuse, you know that neither of the two would work, right? Because we have opposite and adjacent. But if you look at tan, we say tan is equals to opposite over adjacent. So the trig ratio that we're going to use is going to be tan. So tan theta is equals to opposite over adjacent. Tan theta is the angle, which is 43.1, is equals to the opposite side, which is N, over the adjacent side, which is 12.5. We put this over 1 and then we cross multiply. So N times 1 is going to give me N. 12.5 times tan 43.1 is going to give me 12.5 tan 43.1. We want the value of N, so we put this into our calculator. So that's going to be 12.5 tan 43.1, and that's going to give me 11.697. Rounding this off to 2 decimal places, it's going to be 11.70 cm, and this is the length of our opposite side. So a quick recap. Remember, we use trig ratios to find missing sides or missing angles in right angle triangles only. Our hypotenuse is the side that is opposite this right angle. And then to identify which one of the three ratios we have to use, we have to look at whatever theta is given. If it's given here, then this becomes my opposite side and this becomes my adjacent side. And if theta is given up here, then this becomes my opposite side and this becomes my adjacent side. Hypotenuse does not change, right? So to identify the trig ratios that we have to use always relative to where our angle is given.